Hey everybody, Matt Morgan here. In this lesson, we're going to talk about electrons and energy levels from OpenStack section 6.3.
In this lesson, we'll talk about the Bohr model, review that a little bit, then go into the Schrödinger equation and how it relates to electronic orbitals. We'll discuss the shape of electronic orbitals, and finally shells, subshells, and electrons.
Our previous video discussed the Bohr model and its relationship to the electron energy levels. Now, the Bohr model did correctly predict the energy of the electron in those levels, but there were some problems. For example, electrons do not orbit the nucleus like planets around the sun. But Schrödinger addressed these problems with the Bohr model, and he found the location of electrons in an atom.
Schrödinger was a brilliant mathematician and one crazy guy. He was Jewish and worked in Germany in 1933. It turns out that was a bad combination. When Hitler took power, he made life miserable for anyone of Jewish descent. So he fled Nazi Germany and moved to England with his wife and his mistress. I guess they were just one big happy family. Okay, back to chemistry. Schrödinger developed a mathematical equation that accounts for both the wave and particle nature of electrons. And there is that equation, very complex, scary actually to look at it. Fortunately, that equation was solved, and it gives us the information about the location of electrons. Now, you don't have to do anything with this equation. Just know that it exists and it has been solved. Electrons don't circle the nucleus in specific orbits like Bohr thought, but they're found in three-dimensional arrangements like shells. These electron shells are called orbitals. They are regions around an atom where it is likely to find an electron. The different orbitals have different shapes. S orbitals are shaped like spheres. P orbitals are shaped like dumbbells. And D orbitals are cloverleaf or X-shaped. There are also F orbitals, and the best way to describe them is complex. Let's look at some pictures of the orbital shapes. The s orbital is a sphere. Here it looks like a circle, but remember that the s orbital is a three-dimensional entity. The p orbital, shaped like a dumbbell with two specific lobes. There's the cloverleaf-shaped d orbital. And finally, here is an f orbital. There are multiple lobes with this, very complex. The Schrödinger equation allows us to know where to find the electrons. It also tells us that there's one kind of s orbital, just that sphere. 3 p orbitals, 5 d orbitals, and 7 different kinds of f orbitals. The equation tells us that different energy levels support different kinds of orbitals. In the first energy level, you are only going to find the 1s orbital. In the second energy level, n equals 2, you can have an s or a p orbital. In n equals 3, what kind of orbitals do you think you will find? Think for a minute. Select your answer. I hope you said that n equals 3 supports s, p, and d orbitals. There's also a pattern that relates the shells, subshells, and orbitals in an atom. First, let's identify what we mean by shells and subshells. The shell is the energy level, n equals 1, n equals 2, etc. The subshell is the same type of orbital, whether it's a 2p or a 3d, that is considered the subshell. Here's a table from Wiley that shows the relationship between the shells and the subshells. In shell equals 1, all we see is the s orbital. In the second shell, we have s and p. The s holds 2 electrons. The 3p orbitals hold 6 electrons. In the third shell, we have s, p, and d. In the fourth shell, s, p, d, and f. If you look at the subshell capacity, you need to remember that each individual orbital holds 2 electrons. There are 3 p orbitals, which is why the p subshell capacity is listed as 6. There are 5 d orbitals, which gives us 10 capacity for the d orbital. There are 7 f orbitals, and the f subshell can hold 14. Here's additional information on the next page. A lot of information here showing us the shell, 1, 2, 3, or 4, the number of orbitals in that shell, the subshell orbital types, the number of orbitals of each type. What you might want to do is pause the video and look at this screen, maybe take a screenshot or print it out. A lot of good information here. Now, you don't have to memorize all this information as it appears on the table. You get a crib sheet that will give this information to you. And that crib sheet is the periodic table. The periodic table will give you the information about shells, subshells, and the number of electrons in each shell. Let's look. Here, this is our shell, energy level 1, 2, and 3. Here's our S subshell, 1s, hydrogen and helium, 2 s's here, holding 2 electrons. Here's the 2p subshell. It holds 6. Here is the 3d subshell. It's 5 orbitals holding 10 electrons. The f subshells are down in this part of the periodic table. So a lot of good information if you know where to find it.
In this lesson, we discussed properties of the different electronic orbitals, their shapes, how many electrons they hold, and where to find them on the periodic table. Next lesson, we will use this information to find an atom's electron configuration. As always, if you have questions, contact me via email. There's my address. We have online office hours Tuesday and Thursday mornings from 9 to 10 a.m. Central Time. And if those times don't work, feel free to make an appointment.